Okay guys, this is the autonomous VEX IQ blocks programming video. So in this video, I will be teaching you guys how to program your robot for autonomous skills for VEX IQ specifically, and then how to plan your kind of robot's route, build your own blocks in order to make programming more efficient, and then yeah, that's kind of what I'll be teaching you about, and then also how to upload, test, and then kind of adjust things throughout the way. So first, this is a pretty big deal when you're trying to program autonomous. Autonomous isn't something that you can just set the robot what to do when certain things happen. You have to have something pre-planned to begin with. So I would suggest not this. I would suggest opening up kind of a VEX IQ field idea and then knowing kind of what you can do and what you cannot do. So I'm going to kind of be developing a plan along with you guys. So if you don't know this already, you can only start your robot on this back field. So let's say I want to start my robot right here. This kind of cube is my robot's initial starting position. And then let's say I want to first, I want to go straight, because if I go straight, I can manage to knock off my this cube. But if I keep going straight, my robot's wide enough to just kind of knock this one off as well. So this is like knocked off. And then this one's also knocked off. So that's like 10 points. And then let's say I want to rotate 90 degrees. Then I'd rotate there, and then I'd go straight here, knock that one off too. And then I'm gonna keep going straight so it wouldn't stop. And then I want to go here and then put my arm down. So my star is going to equal arm down. And then I'm going to, yeah, that's all I'm going to do for this autonomous. Just to teach you guys different things like turning, driving, and then moving your kind of different components. So just to kind of reference you guys, autonomous programming takes a lot of trial and error, especially the way I'm going to teach you guys, because right now, you guys should be at the point where you're learning time-based autonomous, aka you're running stuff based on kind of different various sensors and approximating when things start, but you're not using sensors like to kind of run exactly what you want. So what I would do now is I would break this down into multiple steps. Now this straight line here is kind of step one of moving. This rotation is step two, because that's a completely different kind of motion. This other straight line is step three. And then putting down the arm is step four. So I'm just going to open up a super quick Google Docs so that I could write this down before I forget. So 1, move straight until far red cube. Then 2, turn right 90 degrees. 3, move straight until supply box. And 4, put arm down. Now for you guys, this is going to be much more complicated than this, and I mean quite a lot more complicated than this, because you're probably going to have more time to run it. that's essentially what I would do. And then I just have a document like that I'd call like 23-24 autonomous plan. So this is just a new document that I'm using to kind of write our plan. Then additionally, what I would do is write kind of a list of different kind of actions that you have. And what I mean by actions is like a certain type of movement. One that I can tell significantly is moving laterally. So actually, if we go back and forth, laterally just means kind of in a straight line. Then we also have turning, which is a pretty clear one here. Lift movements. And then another one I would have is just setting speeds. I don't think you understand how many times you change speeds. I'm gonna have it move at 60% speed here. And then I want it to move 80% speed here. And why I'm saying this is because if you look at it here we have no stopping point. You can't physically hit something to stop. But if we go here, it's okay if you overshoot because we'll just hit the wall here. That's the kinds of things you have to think about. And then turning, you want to be a little bit more cautious. We're just going to go 70% speed. You can also make something to change the arm speed, but it's essentially the same concept. And since the arm is only one motor, you can technically just do one line of code and it'll be fine. But yeah. What's super beneficial about making a plan like this is that it's really straightforward to program once you have kind of your blocks. So I'm just going to label this blocks to code, and then at the top, this is actions for autonomous. Okay, cool. Now we're gonna open up our VEX code. So if you don't remember now, press the spot here, the little magnifying glass key on your Chromebook, or your Windows key or whatever you're using, kind of your search key. That'll open up your little tabs for VEX Code IQ. For this one, we cannot use our prior project. So you have to actually open up a new file because essentially that one, it's running stuff for your controller. This one has nothing to do with that. So we're gonna do new text project, new blocks project. Sorry, I'm kind of laggy. And I just realized this isn't the same thing as before. Big thing, you want to switch it over to a different slot. Your original programming was saved in slot 1. And if you download it, it'll overwrite it, which means you'll lose that code and you have to re-upload it. So if you save it to another slot, I'll show you how that looks on a Cortex later on, but it'll just save it to a different slot, won't overwrite anything. Next, we want to rename it. We're going to name it 23-24 autonomous, because that's what it's looking at. Daily materials. No, student resources. And then this is just where I'm storing all of my code, a ton of different things for just robotics programming. I have videos in there that I've made and different testing codes that I've done. I wrote this down, but this is essentially what you have to reinitialize all of your things. So if you haven't done this, watch part 1 and part 2 of the user control, because it's kind of important to understand how this works. So I have a controller, we're just gonna add that. I have a device, I have a motor, which is in port 6, called left drive. I would try to keep everything the same name just to kind of keep track of things easier. I do not have a bumper. Oops. Add a device. Motor. Port 12. Right drive. This one is reversed. This isn't part 1 on how to determine if it's reversed or not. and then I have a lift, port 1, just doesn't matter if it's reversed. Okay, so essentially what's gonna happen is we have to do something called defining a block. A block is like any of these. This is a block, that's a block, literally any of these that don't have this kind of weird like bumpy thingy at the top. Those are all blocks. If they have this, it's pretty much something called an event, just constantly checking for things to happen. I explained this in part 1 and 2 again of it. But essentially what a block is defining a set of actions to happen with just one block. So essentially I'm going to be reusing certain actions multiple times. Not specifically in the example that I'm going to program, because for me, I'm just going to do 4 simple actions. This list could be very long for you guys or very short depending on how complicated you want to make it. You might be doing the same actions like 15 different times, so having a block is very beneficial, and you'll see why. So to make a block, we're going to click here. We're going to call this one drive, because this one's going to set our lateral motion, this one, and then we're going to add a number. And this is going to be our amount that we want to move. We're going to click OK. Now, to explain this like completely fully, essentially, we're going to have a ton of blocks here. This is an amount that we do not know. It's going to change basically every single time we use this block. So this block is what's actually going to run, say, when we start a code. But then essentially when this block is called, it's going to go jump over here, run the code that's in here, and then jump back here. You'll see it more when we have multiple blocks defined and what those do. But for now, we'll just work on defining drive. So drive is how much we want our motors to move. So let's say we want to know how many degrees we want it to spin. Let's say we want a motor to spin, I don't know, like 200 degrees, but we also want it to move, like run it. So which block of code here do you think sets it the best to move however many degrees? Okay, it's this one. And the reason you might have thought it's this one because this one's also talking about degrees, but the reason it's not is this is to position. Let's say your wheel or your axle. Say this is your axle. This is position 0. This is 90, 180, and then 360. Let's say your axle is currently in like this position right here. If you tell it to spin 90, it'll spin to here. But if you only wanted it to move 90, you want it to move to just like here. So it's important to identify that you want it to move 90 degrees and not to the position 90 degrees. Because essentially these motors have like little sensors to determine what their position is. And that's very different than moving a certain set amount of degrees. So we have 2 motors for our drive, so essentially we want to define 1 block for each, left drive and right drive. Now essentially what will happen is we'll move left drive forward 90 degrees and then right drive forward 90 degrees. But if you see this little arrow, it says, if we click it, it says, and don't wait. So essentially it'll run this code and it'll run this one next. But if we have this one, if we have something down here, it won't wait for that. Or let's say we have the drive block. I can't do that. If we have the drive block here and then like another block of code here, and we have this here, it'll run this, jump back here, and then continue running down here. Which is not what we want. We want it to run solely 1 block of code at a time. 1 block of code that we make at a time. So we want it to wait. But I want you to look at this and tell me what's the issue if we want the drive to be different amounts for different kind of motions. So essentially, we're setting it to always be 90 degrees. And that's exactly what we don't want to happen. We want it to be the specified amount. So if we look at this is pretty cool. We can drag out the amount specifically and put it in the 90 degrees. Now, if you remember in the first video, we talked about how different like shapes match with different things. It gives us a pretty good clue about this. And if you also remember in the first video, we talked about kind of how drives work, how motors work. If you give it a negative amount, it'll just run in a negative direction. Therefore, if we set like negative 100 degrees, it'll go backwards, which is really cool because then we can avoid ourselves writing another block of code. So I'm just going to write a quick note to myself, be like, positive equals forwards, and then negative equals backwards. Just a kind of a reference of which way it's going and which way it doesn't go. That's our first block. We're gonna just bold it to note that it's done. Next we want to do turning. This is another pretty big one. Actually, all of these blocks are kind of important. Turning. And then we also want to define our amount. How much do we want to turn? Just gonna put this right next to it. Pretty big hint. We can actually use most of the code we have here, because if you remember, basically turning is the same except one is forwards and one is backwards. Now, if you recall, if the way that you turn in a certain direction, it's, let's say I want to turn left, then I'll put my left one negative, right? So the easiest way to make this turn is to just set one reverse and one forward. Now, what's really cool about having the same names for different things is that you have something called scope. Not going to go into it. This is a pretty big programming thing, but essentially this little block of code only exists to any code in here. I can't really use it here. It'll turn gray because it doesn't exist outside of this outside of code that isn't under this block. So I actually have to use this amount, drag it in there, and this amount and drag it in there. Everything else is perfect. Now if I go down to my comments, I just want to give myself a little hint as to which way is spinning in which direction. And if you remember, reverse means that that's the way that we're turning. So that means any positive value that we give it equals left turning, and then any negative equals right. If you don't understand this, it's completely okay. It's kind of difficult to kind of visualize. But essentially, if you try driving, if you put your joystick in the negative direction, that's the direction that you're going to turn in. I would suggest kind of testing out driving your user control just to get an idea of how this works a little bit better. That gives us our second block of code. Now we want to define our lift kind of movements. I believe we can call it lift even though we already have a motor named lift, because the code knows that it's two different things. It knows that it's a block and it's a motor, and they're kind of not related to each other, so we don't have to worry about that. And then number amount. We're going to call it an amount just to be constant. That's what we've been calling it for everything else. Motion. We're going to do essentially the same thing that we did up here. Move forward for set amount, but we want to change our motor name, which is lift, and we're not going to activate this because we want it to stop and do whatever it needs to do before moving on. And then we also need our amount. Now for me, I have a weird lift because it doesn't actually do anything, but positive equals moving to the left. If you haven't watched my second part of the user control video, you won't really understand what it means. But then my negative equals to the right. Your positive may equal moving up, and then your right negative equals moving down. It all depends on how you build your robot. Once again, programming is gonna look very different for every person because every person has a different robot. Therefore, everything does different things. So now we have this code done. And now we just have to set our drive speed. So the reason I'm doing this is because it's way easy. If you remember, you have to set velocity for each one, and you have to change the motor name, and you have to change the amount, and it's 2 blocks of code each. You can just save a lot of work by just making it 1 block. We're gonna call it drive speed, and then number, and then speed. So I want you to take a look. Tell me what block of code we'd use to change the speed of our motors, or velocity. It's going to be this code. We need 2 because we want to change both, so we have to do right drive and left drive. And we want to set our speed not to 50% because that means we're keeping it the same for everything. But we want to use the value that we input as a block. So if you go to comments, I'm just going to write myself a little quick note, reminder to put a value that's between 0 and 100. Just to kind of remind myself that that exists. Now we're going to actually program the steps that we want. So now that we have this part out of the way, our blocks of code, I'm going to unhighlight everything because it's not a title. It's kind of annoying me. But first we want to move straight until far red cube. So if we start here, we want to move straight until like here is where we defined it. So we want to drive. And if you remember, positive equals forward and negative equals backwards. I'm just going to set it as a random value for now. We're going to set it to 600. That's 500. I don't know why I said 600. Drive. Now what I would do as a little quick note is we're going to do step 1 because it's step 1 in our plan. Now in terms of notebook, I'd actually highly suggest writing out this plan. Basically everything in this Google Doc is really helpful for your notebook. And then if you want, you can print out your code. Can I print out this code? You can take screenshots. If you don't know how to take a screenshot on a Chromebook, it's Control-Shift, and then whatever kind of thing that popped out. It's like the little rectangle with the 2 lines. I'll kind of draw it out. If you press that, you can just, it's on your top row, or it should be at least. If you press that, you can screenshot and then figure out a way to print it out and put it in your notebook. And then essentially your judges can you can tell your judges to refer back to actions for autonomous to show what each step is supposed to do, as opposed to having 100 different comments trying to explain and then not have an actual detailed plan where it's not as clustered. So step 1 was to drive 600, but we actually forgot our 60% speed. So we want to do it before we do it, because if we do it after, it'll run at the speed that it was before, which it defaults to 50 by VEX code, and then it'll set our speed for the next section, which is not what we want. So we're going to go to drive speed, and we're going to call it 60 because we set it to a percentage, and 60 is the value that we talked about in this section. Then we want to turn right. We're going to use our turning. I'm going to write a little comment. So step 2. You could want to set our drive speed as well. We're going to call it 70 because that's what we wrote down in our action plan. And then turning, we want to remember that negative equals right. So I'm just going to set a placeholder value. We're going to set 300. Now I'll show you guys what I mean that these are placeholder values, because it's very unlikely that it's going to actually run turn 90 degrees. But we'll worry about that later. Next we want to do step 3, which is to move forwards again. but we're gonna set our speed to 80 because we're not as worried. 80. And then drive forwards. It's about, I don't know, 500. And then we're gonna do our step 4, which is lifting our arm. I forgot to say this in my action plan, but let's say we want to run our arm at 20% speed. I don't know if you remember, but my lift is incredibly fast because of the way I built it. Once again, don't copy my builds because they're very bad and they don't actually work efficiently. Just for educational purposes. So lift 20%, and this is what I meant that we didn't need to make a block of code to set our lift speed, only because our lift is only one block, and so we only have to put in one value anyway, so it's not worth it to go through all the hassle of writing it out. But then we're gonna move our lift. We're gonna move it forwards, I don't know. And then we're gonna move it 30 degrees. This is all of the code you need in order to do this. So now I'm going to show you on my floor. I'm gonna have kind of a little makeshift course because I don't have a full-size field in my room, just to demonstrate on how to do adjustments. Okay guys, so I have a little bit of a different setup right now. I currently have 3 post-it notes on my floor, kind of signifying different spots. That is the wrong thing. So this first post-it note is my starting position. That post-it note over there is going to be kind of, if you look at the Chromebook here, kind of this position over here, and then that post-it note over there, we're gonna pretend it's the supply chain spot, the supply box over here, right here. Only because I don't have a field like in my bedroom. So my battery, I was charging it, forgot to plug it back in. So I'm gonna plug that in real quick. I have my compiling cable already plugged into my Chromebook. I'm gonna plug that into my controller. Move that camera back a little. So we have to turn on our brain. We're gonna pretend that my thing starts right like here. I don't know. Oh. Somewhere in this general area, because like for me it's not that important how much it spins as opposed to the fact that it does spin. So let's say your bot starts like somewhere around here for scientific purposes, obviously, because it's very precise. We're gonna just download it. Okay, great. So I'm gonna have to update my code, my brain. So give me like a minute to do that, because if it gives you an error where it says it needs to connect over a USB connection, it's like systems files update over that. It means that you can't have your thing plugged into the controller, but you have to plug it into there. So this is a great example of that. So now I'm just gonna demonstrate that. So sometimes unplug it, refold it, plug it in, download. Now it's talking about downloading Python files, which we are not programming in Python for this, by the way. So that's just meaning it's doing like an update. Okay. Now we can plug this back in to here. We're just gonna re-download this for good measure. And actually, I just realized something silly I did. You don't need a controller for this. Actually, I discourage you from having it, so we delete it. just so that you can avoid accidentally programming something that uses your controller, because you're not allowed to do that. So we're just going to run it for funsies because this is 99% going to fail and probably crash into the wall or my bookshelf. So you can see that it way overturned. It did not reach the second post-it note by any means. So for now, I'm actually just going to remove the blocks of code after step 1, just so that we can focus on one movement at a time, aka getting to the post-it note first, and then I'm gonna slowly add on steps just to demonstrate this. So we're gonna re-download this, and we're gonna take a look at how far I actually got to that point. Okay, I'd say got a solid 2/3 of the way there. So we're gonna add on half of that. So we're gonna say our drive is 900 now. You 100% do not need to know a ton of math to do this. You can just do trial and error. It's like, oh, if it's too short, we're gonna add on more. And if it's like too far, it's overshooting, like it's going way past the post-it, we're just gonna reduce the amount. So there's 90. Actually, that's pretty close, but we can say like like 1,000. And by 1,000, I mean degrees that the motor spins. By the way, that this is just an example of why you shouldn't copy my designs. This lift is so bad that you can't even grab it without it breaking. Perfect. That's exactly what we want. So now we can add step 2. And if you remember from original test, it turned 90 and then it turned like 45 degrees more. So I would say we want about 1/3, 2/3. So that's 200. So now we're gonna download it, grab this, reset it, and then we're gonna test it again. Why are you giving me errors? Okay. Now we're gonna run it. We can use the run button or Chromebook, which is exactly what I'm using. That's pretty solid. That's 90 degrees in my opinion, or at least as close as 90 degrees as I want to get into this video. And then, okay, so if we look from here to here, that's about like 75% of this. Once again, you definitely don't need to know what that means. So we're gonna add on step 3 now that step 1 and 2 are like functioning. So 75% would be 750, or like 3/4 of 1,000. So it keeps giving me these errors. You're gonna download it, reset our robot, and then run it to test. Okay, that reached the 3rd post-it. Now, if you don't remember what my first attempt looked like, go back, look at it, because it was pretty nasty and it definitely did not do what I wanted it to do. But now we can add our final step, which is to move our lift. The reason I'm getting all of these attempts like first try is because I'm pretty good at estimating the distances. Okay, so my lift isn't working. Is it trying to move? Yeah, it's definitely trying to move. So that means I did something wrong. My lift probably meant that negative equals left, and my positive equals right. So I'm just gonna switch this over to a negative value, negative 30 degrees. We're gonna download it and redo it. Of course it failed. Now what I was saying is that I'm pretty good at estimating values, and I'm also doing this really fast because this video is already like 40 minutes long. But it's 100% okay if it takes you more than one try to estimate this stuff. Wow, and I forgot to reset this. So let's just run that one last time. Hopefully it works. Oh, can't set it up wrong. That's okay. Okay, there you go. We saw it move up. That's essentially the 4 steps we had programmed. You can 100% have more than that. This is just for demonstration purposes with the list that I created. And don't worry if it takes you more than 1 attempt to do it, because as you can see, it took me like 3 attempts for the lift, but it only took me like 1 attempt to do like the 3rd step of moving from there to there. Just test out values, kind of estimate how much, like in terms of values, like 1,000 for me means moving from here to all the way to that posted, but 1,000 for you could mean moving from there to my wall over there, or 1,000 could mean from here to like halfway. But what I did is I was just good at estimating, like, oh, if it ran from 500 from here to here, that means it's gonna 600 from here to here. That's gonna be like 1,000 to that point. And if it ran, and if this is like only a small, like, I don't know, a good chunk more of that means like that's like 3/4 of the value from there to there. So that's how you use kind of simple kind of fractions to do that, but you can just do trial and error, be like, okay, we're gonna do 300 and then 400 and 500 and see where it gets us. But yeah, that's it in terms of autonomous programming. Don't worry if this takes you more than 1 day to do it. For me, autonomous takes me multiple days. But yeah, that's it.